thing as the last section. We're going to come up with some derivations again, come up with some formulas for what we call our half angle identities: sine of some angle over 2, cosine of some angle over 2, tangent of some angle over 2. And we'll start with sine of alpha over, or a over 2. And where this identity comes from, it comes from the double angle identity cosine 2x equal to 1 minus 2 times sine squared x. So let's start with that true equation. Let's start with cosine 2x is equal to 1 minus 2 sine squared x. And let's solve this for sine of x. So let's start by subtract 1 from both sides. Gives us negative 2 sine squared x. Let's divide both sides by negative 2. So I'm going to write that as, I'm going to put the sine squared x on the left. And by dividing by, if I bring that over there to the left, this will be equivalent to 1 minus cosine 2x, all of that over 2. And we'll go ahead and take the square root of both sides. Giving me this. And I have to leave the plus or minus in the formula because at this point we have no idea what quadrant that we're dealing with. So we would simply pick the positive or the negative version depending upon what quadrant that we're going to be working in. We're not quite done yet. Now the last step, folks, is to put this in terms of some angle divided by 2. So take a look at what would happen if we let x equal a over 2. Wherever you see an x, let's put in a over 2. So this x comes out. We replace that with an a over 2. And inside the radical part of this, I put too many x's over there, by the way. Right here, let's take x out and put in a over 2. Well, 2 times a over 2 is just a, giving us the formula that we need to end up with. So the sine of a over 2 is plus or minus square root 1 minus cosine a over 2. Meaning this, if you needed the sine of 15 degrees, you're going to let a be 30. See what I mean? See what happens on the left? 30 over 2 gives you 15, but that allows you to use 30 on the right-hand side, which you already know this is one of your special angles. And again, you're the positive or negative you choose depends upon what quadrant that you're in. So there's the sine of half angle. Now we'll take a look at cosine and tangent. We're going to do the same thing as we did last problem. We'll start with one of the double angle identities. And in this case, we'll solve this one for cosine x. So I'm going to go ahead and add 1 to both sides, giving me 2 cosine squared x equals cosine 2x plus 1. And we'll go ahead and divide both sides by 2. And we'll go ahead and take the square root of both sides. Plus or minus square root cosine 2x plus 1 over 2. And just like with the last problem, let's let x be a over 2. Let x equal a over 2. Well, that x comes out. That x comes out. 2 times a over 2 is a. So we end up with that. cosine of a over 2 plus or minus square root cosine a plus 1, all of that over 2. Any questions so far? Again, we're simply deriving these things, and then we'll take a look at specific cases where you actually would use these for some basic short answer type questions. The tangent of a half angle. Here's one correct form. We'll tackle this as the approach. Well, tangent's the same thing as sine divided by cosine. And those two that you're looking at there, we just got done deriving. So up top, sine would be plus or minus square root of 1 minus cosine a over 2. Over plus or minus square root of 1 plus cosine a over 2, which is the one for cosine of a half angle. And you have a radical in the numerator, radical in the denominator. You can make that one big radical. This is the same thing as plus or minus one big radical. 1 minus cosine a over 2 over 1 plus cosine a over 2. But again, dividing by that second fraction is the same as multiplying by the reciprocal. So imagine flipping the second fraction and multiplying. Your 2's are going to cancel out, and you're left with plus or minus 1 minus cosine a over 1 plus cosine a. So there is one of your derivations for tangent of a half angle. That's one. I'll show you another one. Isn't used all that often, but at least it's there in case you'd like to use it. It might, for a certain problem, for a specific identity that you're working on, maybe this one would come in handy to eliminate 4 or 5 steps within an identity. If we go back to tangent of a over 2, and again start by thinking of this as being sine of a over 2 divided by cosine a over 2. Start there. And now let's multiply top and bottom of that equation. We're going to multiply top and bottom of this fraction by 2 cosine a over 2. What does that do? Well, what's that give us up top? No, up top. What's that the same as? Maybe if it was written as 2 sine a over 2 cosine a over 2. That sounds familiar. That's the sine of a double angle. So up top, we have the sine of 2 times a over 2, which is just sine a. How about the bottom? Well, the bottom we're going to have 2 times cosine squared a over 2. And that's the same thing as 1 plus cosine a. So we end up with sine a over 1 plus cosine a. Again, you used a double angle identity up top, and you used a double angle identity on the bottom to come up with the second possibility. Just another equivalent form for tangent of a half angle. Maybe it will come in handy. Maybe you'll never use it. I don't know. I can't see the future. So the summary, again, here are there is one more equivalent form. You and I derived this one and this one. Just know that there's another one out there as well that also holds true. All 3 of those you can use for the tangent of a half angle. Question? Just stretching. I'll move it along. So now let's try to come up with the exact value cosine 15 degrees. So we can now view this as, like I mentioned earlier, cosine of 15 degrees, we can think of it as being the cosine of 30 over 2. 30 degrees. So I look up at my cosine of a half angle. It's going to be plus or minus 1 plus cosine A. One plus cosine A. A would be 30. Remember, this is A over 2. So A would be 30, all that over 2. And since we're in quadrant 1, we can eliminate the plus or minus. We know it's going to be the plus version. So what do we got so far? Well, we have, it's going to look ugly at first, but we're going to have 1 plus cosine of 30 is square root of 3 over 2, all of that over 2. So let's multiply top and bottom by 2. It gives us a 4 on the bottom, and I got to use distributive property up top. That gives me a 2 plus root 3. Now it's the square root of all of that. And now's where we can take the square root of the top, square root of the bottom. So we have the square root of 2 plus the square root of 3. Yeah, you got a radical within the radical. But on the bottom, square root of 4 becomes 2. So right there's the cosine of 15 degrees in exact form. Square root of 2 plus root 3 all over 2. Questions with that problem? All right, I'll let you work on this last one. See what you come up with. Here we have the cosine of S is 2/3. We're told that S is in quadrant 4. Find cosine, sine, and tangent. So again, we're going to probably need a right triangle over here. Cosine of S is in quadrant 4. So that tells us x over r is 2/3. R would be 3. X would be 2. And what's the missing side end up being? 9 minus square root of 5, right? In the negative direction. Now you guys all know that these 3 formulas have plus or minuses out in front of them, right? How do you know which one to pick? Yeah, I know that S, guys, I know that S is in quadrant 4. But how do I know where S over 2 is? So take this inequality right here and divide all 3 spots or locations by 2. Divide everything by 2. Do you see how that gives us an S over 2 in the middle? Gives me a pi out here. And 3 pi over 2 times 1/2 would be 3 pi over 4. So if S is in quadrant 4, S over 2 is in which quadrant? What do you think that quadrant would be? You're less than pi, more than 3 pi over 4, you're in quadrant 2. That's the quadrant that S over 2 is in, which tells you which one you want to pick in terms of plus or minus. So let's do cosine of S over 2. Cosine of S over 2 is plus or minus. Cosine in quadrant 2 is negative. So we'll pick negative square root of 1 plus cosine S. 1 plus cosine S, that's given to me in the problem. Cosine S is 2/3. all of that over 2. And that ends up being negative square root of 5/3 over 2, 5/3 times a half, square root of 5/6. And then when we rationalize the denominator, we get the square root of 30 over 6. Questions with cosine? Sine of s over 2. Again, s over 2 is in quadrant 2, so this one's the positive version. So positive square root of 1 minus 2/3, or 1 minus cosine s, which is 2/3 over 2. And that ends up being the square root of 1/3 over 2, which is 1/6. Square root of 1/6. That's the square root of 1 over the square root of 6. That's 1 over root 6, which would be root 6 over 6. So here we have cosine. Here we have sine. Again, it's completely up to you. You know you have these formulas for tangent, right, of s over 2. However, I take the approach, hey, I got sine and cosine looking right at me. Let's just divide them. So tangent of s over 2, I'll think of it as being sine divided by cosine. Sine of s over 2, square root of 6 over 6, divide that by negative root 30 over 6 is equal to negative root 6 over root 30. And that simplifies to what in lowest terms? Negative root 5 over 5. Okay.